In section 5.2, number 51, we use this diagram to compute the sine of A, cosine of A, and tangent of A. And A is defined in this diagram by this large angle that is the sum of 30 degrees plus theta, but we don't know what theta is. So we can use the sum identities from section 5.2 to find sine, cosine, and tangent of A by finding the sine of 30 degrees plus theta degrees. But to do that, we're going to need, we'll need cosine of 30 degrees, sine of 30 degrees, and tangent of 30 degrees. We know these three from the unit circle. Cosine of 30 degrees is radical 3 over 2. Sine of 30 degrees is 1/2. I think I have those cosine. I'm sorry, I think I have those reversed. No, that's right. Okay. And then the tangent of 30 degrees will be sine over cosine, which gives us 1 radical 3, or radical 3 over 3. And we need to find cosine of theta, sine of theta, and tangent of theta. But we don't know what theta is, so how do we do that? Well, we do have some hints because we have a 5 and a 12 over here. If I had that third side, then I would be able to find. So what we're looking for here is this purple triangle gives me the trig functions associated to that small angle. And I have the 5 and the 12 that correspond to it. So these three numbers I can get from that purple triangle. Okay, so I can use my Pythagorean triple if you happen to know those by heart. If not, you can always just do the Pythagorean theorem and get 5 squared plus 12 squared to get that third side equals c squared. So then c equals the square root of 12 squared plus 5 squared, which equals the square root of 144 plus 25, which is 169, and that is 13. So this last side is 13. So now I can fill in those sides. So cosine of theta, here's our theta. So cosine is going to be that's adjacent over hypotenuse, so that's 12 over 13. Sine is going to be 5 over 13. And tangent is adjacent over opposite, so that's 12 over 5. I'm sorry, 5 over 12. Opposite over adjacent, tangent. TOA, right? TOA. Okay, so now I have all the information I need to use those identities given in 5.2 to find sine of A, cosine of A, and tangent of A. So now to apply those identities. So let's do the first one. So sine of A equals the sine of 30 degrees plus theta, which equals, according to the identity, sine of 30 times cosine of theta plus cosine of 30 times sine of theta, which gives me cosine of 30, looking back at my list right here, I get radical 3 over 2. Cosine of theta, I have my list right here, and that is 12 over 13. Plus cosine of 30 is, whoops, I think I wrote the wrong thing, sorry. Cosine of sine of 30, 1/2. Cosine of 30 is radical 3 over 2. And sine of theta is 5 over 13. I think I copied everything right now. That looks good. And that gives me 12 out of 26 plus 5 radical 3 out of 26, or I could rewrite that as a single fraction like that. So there's my sine of A. Okay, I'm going to shrink that up now so I can now find the next part, part B, which asked for cosine of A. Let's do that one in green. So now we're going to do cosine of A, which equals the cosine of 30 degrees plus theta. And now we use the other identity, which is cosine of 30 degrees, oops, that's a theta, times cosine of theta degrees. Change the sign. And then we do sine of 30 degrees times sine of theta degrees. And then we can plug and chug. Cosine of 30 gives me the radical 3 over 2. Cosine of theta gives me 12 over 13. Minus sine of 30 gives me 1 over 2. Sine of theta gives me 5 over 13. That gives me, can do a little bit of simplification here. 2 and 12 reduced down to 1 and 6. I think that's all I can do. Which gives me 6 radical 3. Oh, I guess that was kind of a waste of time because I have to combine the common denominator, so let's undo that. Okay, so then I get 12 radical 3 over 26 minus 5 over 26, so all of that over 26. That's my final answer for cosine. Okay, so cosine and sine are done. I'm shrinking that one up now so I can do tangent of A for part C. And I can actually scroll down since I don't need cosine and sine. So let's do that in a new color. How about this blue? So tangent of A equals tangent of 30 degrees plus theta, which equals tangent of 30 plus tangent of theta all over 1 minus tangent of 30 times tangent of theta, which equals radical 3 over 3 plus 5 over 12, using that table we made up in the above with all the raw data. And in the denominator I have 1 minus the product of those. So getting a common denominator of 12, let's see, that's 4 radical 3 over 12 plus 5 over 12 all over, let's see, 5 radical 3, 12 times 3 is going to give me 36. So I'll do it, instead of 1, I'll do 36 over 36 to get my common denominator. And now combining a little further, I get in the numerator I get 4 radical 3 plus 5 all over 12. And instead of this big fraction bar right here, I'm going to do a division sign so I can sort out my fractions. So in the second part I have 36 minus 5 radical 3 over 36. Okay, when I flip the second and multiply, then I will be able to reduce by a factor of 12. Which leaves me with a final answer of 3 times 4 radical 3 gives me 12 radical 3, plus 5 times 3 gives me 15, over 36 minus 5 radical 3. This is an acceptable final answer for tangent of A. You may find an alternate form, let's see, with moving the radicals around by multiplying by radical 3 over radical 3. And then you would see 12 radical 3 times radical 3 gives you 12 times 3, or 36, plus 15 radical 3 over 36 times radical 3 minus 5 times radical 3 times radical 3 gives you 5 times 3, or 15. But then when you do that, you can reduce a factor of 3 out of each term, not just the numerator and denominator, but each term. So a 3 from here would leave you with a 5, a 3 from here leaves you with a 12, and a 3 from here. And that gives you a final equivalent answer of 12 plus 5 radical 3 over 12 radical 3 minus 5. So you may see either of those answers.